All right, looks like we are recording. Um, I'll just quickly go over what I just said. We have a simple agenda today since this is the first public meeting. For the people that have shown up, I was thinking we could do introductions so we understand what we're all working on, what our interest in this project is, and what we'd like to do with it. Quick Q&A about the Patina project. And then we've run this meeting with a smaller set of people, and we often go over our RFCs. That is the big work items that we're planning to do in the near future, that people have written down what they want to do and how they want to do it. So we'll go through some of those to look at some of the big work items happening in the project. And then if we have any remaining time, we'll go over some active work happening so developers can be in sync with what's going on and we have chances to comment on that work. That being said, are there any starting opens that people have that may not be covered by these agenda items? All right, if not, I'll start the introductions. So my name is Michael Kabaki. I'm an engineer in the core UEFI team, as many of the other people on this call are. We started work on this Patina project a while back to be able to replace the C-based Dixie core with a implementation written in Rust. And the main thing that we want to proliferate with this work is memory safety and UEFI firmware. And the Dixie core is a start to that. So that's the Patina project started with the Dixie core, but you'll see in some of the RFCs, there's plans to expand into places like potentially BDS or the core and things like that. So it's really about rewriting UEFI based firmware from the ground up in a memory safe language. And with that, I can hand off to, I guess, anyone who would like to go next.
Sure, I can go. I'm Oliver Smith-Denny. I'm also on the core UEFI team. And I own memory protections, paging, CPU related stuff, and often whatever's broken in Patina. Nice to meet folks.
I can go next. Hi, I'm Joey Vagadis, also on the core UEFI team. I focus mainly on the Patina component system, which is like the monolithically compiled components instead of using like typical UEFI drivers and such that can be compiled directly into the Patina core. I also focus a lot on our testing. As an example, I wrote the Patina test macro system, which allows us to automatically find and execute tests on host-based systems and things of that nature.
And then I'll pick the person to help this just keep going seamlessly. So Chris?
Sure. Yeah, my name is Chris Fernald. I'm also on the core EFI team. I've been working on a number of things within the core, most notably the debugger, but also done a decent bit of work on various other things and the paging exceptions and other kind of low-level CPU stuff. Yeah.
All right, thank you. Sean?
Yeah, I run our core UEFI team. I haven't written any code in the project, but I'm here for architectural guidance and help. I'll leave it at that.
All right, Karan?
I'm a program manager in the WSSI team. So I work with Sean and his team and others on the call for sort of that type of issues. And I'm also involved in the ODP effort overall.
All right, thanks. Aaron?
I'm Aaron Pop. I'm on the core UP team, and I've been working on some of the stack cookie implementation for Patina.
All right, thanks. Vanille?
Hey, I'm part of the Core UEFI team. This is Vinil. So I'm responsible for implementing the stack trace functionality in Patina and primarily look after other related Patina projects, mainly Patina QEMU and other projects.
Thanks. Thorsten?
All right. Yeah, my name is Thorsten. I'm with NVIDIA. I haven't written much UFI code. Well, I guess going back to IBM Hummingbird BIOS days. I'm basically the primary architect for our N1X UFI implementation, and also I used to lead the UFI team at Lenovo for all Think products. And just really looking to get your guidance, get a feel for what direction you're going in, and making sure that we're aligned and that we also recognize and also influence, I guess, what you guys are planning.
Right. Thanks. Daniel?
Hi, can you hear me?
Yeah, there's a bit of like a static or something, but we can.
Okay.
I can hear you.
Yeah, I'm Daniel. I work at Framework Computer, and I do the BIOS and EC and many different types of firmware. And I'm curious what the project is about, where it's going, and how other parties other than Microsoft can get involved or can take advantage of it.
All right. Thanks. John?
Yeah, I'm John Schock. I am the UEFI architect for Surface here at Microsoft. Been involved with Patina since the inception. I did a lot of the early work on like the protocol database and eventing system and the memory allocation stuff, which the team has graciously managed to take towards production for. But yeah, I've been pretty heavily involved in some of especially the early work on it. And a lot of my role right now is, but does it run on hardware kind of elements of Patina. So bringing it into our Surface designs.
Thank you. Ron?
Yeah, hi. I'm Ron Gurr. I work in the WSSI team with Karan. My primary focus is taking Patina and make sure it works with ODP and helping OEMs bring up their own silicon or their own platforms. So mostly external facing, but I am working with code every day too. So it's more of a low level coding type of project I'm working on.
Thanks. Doug?
Yeah, I'm Doug Flick. Also on the core UFI team. I'm not directly related with Patina, but I'm mostly just curious to see the direction of how it's going and as other parties get involved in it.
Thank you. All right. I think that covers everyone that I see in the meeting. So we'll consider the introductions done and move to Q&A. This will be a portion where I think in particular, Thorsten and Daniel, you're the two external attendees. So if you have any questions at all, this would be a great time for us to be able to answer them or clarify anything that you would like to have clarified about the project.
Perfect. It takes a while for my system to unmute, so apologies if there's a delay.
No problem. Would it be helpful for me to cover any particular area of the project, or if we have an expert in that particular area, they could talk about it that's of interest to you or anything like that?
So I guess,
Can I jump?
Sorry. Go ahead, Carl.
Sorry. Yeah, sorry, Michael. I think it would be useful to add just a little bit of commentary around, because external sort of company org charts can be hard to negotiate for people. So I'll just say, like, for the external friends that we have here, what you may have noticed is there's 3 teams from Microsoft that are on the call. There is Sean and his team. They describe themselves as the core UEFI team. So they own sort of the UEFI, the core UEFI components, and that's delivered both for our in-house sort of Azure VM stuff, and then also used elsewhere. And that elsewhere is where two of the other teams come in. So Ron and I are from the WSSI team, and I think Daniel's aware, Thorsten's aware, we've met with Thorsten before, but for Daniel's benefit, I wanted to say that the WSSI team in specific sort of owns the ODP organization that we are referring to here. And then broadly speaking, we are involved with doing a lot of the OEM integrations and working with our OEM partners. So Daniel, if you want to follow up after this on how you can use this stuff in your systems, then a group of us can follow up on that. And then the third contingent that shows up here is, of course, John, who's from the Surface OEM side. So just wanted to clarify that, because at least I know sometimes I join, just organizations can be hard to follow sometimes externally. So I wanted to point out those three contingents are separate. Sorry, Thorsten, I hit go ahead.
No, that was, by the way, that was actually very, very useful. And also adds a lot of good context. Thank you. Thanks so much. Well, I guess from my perspective, by the way, I really appreciate what you guys are doing. I'm also part of a number of other organizations, amongst them also the Trusted Computing Group. So well aware of, I'll call it below the OS vulnerabilities and the increase in attacks on those. And so I really, really like this. I guess if you could go a little bit into, I guess, how you see the evolution of Patina, and then having come from working with working for an OEM for many, many years, and having to deal with IPv complexities, ODM complexities, and then in-house developed BIOSes and UEFI code, and everything else like that. And then also now looking at it from the silicon side of things, right? One of the things that I'd be really interested in is, I guess, from a coding perspective, and then also from a packaging perspective, what's a little bit of, could somebody share with me what your strategy is in terms of making sure that this still aligns with standards and that we're not breaking those standards, and and then also your approach into pulling partners in. Let's say, for example, I want to do a Wi-Fi card. I want to enable a Wi-Fi stack in UEFI, right? How you guys are looking at partnering with other industry partners in this space to make sure that this becomes a viable solution. That would be my question. I know I think that was 3 questions, but yeah. And now I'm going to go on mute.
Okay, thank you. So I think to answer the first question, I'll start that. Others can feel free to jump in as we go through it. But we started this project with the idea that we wanted to modernize the way firmware is written. So it's not just taking what is essentially in the EDK2 code base, which is the primary implementation used in a lot of the systems out there, and rewriting it in Rust. We had to balance compatibility of specifications like the UEFI specification and the PI specification, which makes up part of the EDK2 code. And we had to do that against certain areas where we thought that it would benefit the overall ecosystem, platform safety, to revise those areas. And so for the most part, we are compatible with the platform initialization specification in the UEFI forum. That is the place where, if you go to our documentation, we will have a few spots. So you can go to a rendered version of our documentation by clicking this here. And in here, we will have some of the Dixie core requirements. And where we've strayed from the platform initialization specification, we've tried to summarize those decisions in this document here. So this is platform requirements for Patina. And you'll see things like we said we don't want traditional SML. we have links to like traditional MIM versus standalone MIM. So there's some rationale for like why that decision was made. These are touch points to a Dixie core, right? And in order for traditional SMM to be dispatched, the Dixie core is involved in that process there. There's some other things in here like that we've also taken away from the PI specification, but the rationales provided for those in terms of UEFI specification, we should be fully compliant with that. So we are not trying to change compatibility at the UEFI spec level with this project. It's mainly within the PI spec level. There's just some small areas that we may revise. As far as other specifications go, like TCG specifications, ACPI specifications, we should have no substantial impact on those unless it's like peripherally related with something touched in this document here. And what we do today, in case it's not clear, is we provide a library crate from this repository called Patina. And that library crate is made available on Crates.io and along with several other library crates. And a platform integrates those to build an EFI binary against the EFI Rust target. And we have a repository where we do that for QEMU. It's called Patina Dixie Core QEMU. And so this is the place where, for example, we will take those library crates and pull them in to the project here, and you'll see us bringing in things from those crates and using them to build an EFI binary, which is the Dixie core. Now, what's produced at the end of all of this is a Dixie core binary that's specific to a given platform. Kind of like in a traditional build process, how you would take a DSC and link library customizations or PCD customizations to build an EFI binary that goes into your Flash image that's customized the way you want it to be.
Yep.
That's essentially what's done in this file. Then we support two dispatchers. One is what we call the PI dispatcher, and that will launch everything in firmware volumes and go through a normal dispatch process. And we also support a pure Rust dispatcher inside. So that whenever Joey was saying he worked on the component system of Patina, he was referring to our ability to be able to launch Rust code within the dispatcher for the pure Rust environment. Now, TCG and ACPI and a lot of those things, those drivers are still going to come from the C-based Dixie drivers as part of that PI dispatch process. So we haven't really made any changes to the way that those would function, simply because we're just launching those as is with a Rust Dixie core. So that's kind of like the high level of where things are at. Now, long term, what we'd like to do, the reason why we went with this pattern, or one of the reasons, is as you can see, it's a balance between allowing us to dispatch hundreds of Dixie drivers on any given platform today, and they basically work as is, apart from the restrictions noted. And it also gives us a pathway to simultaneously be able to launch pure Rust code alongside that with the pure Rust dispatcher. So looking forward, it's possible that we might say, let's take some of the TCG implementation that's out there today, and instead of launching TCG to Dixie or whatever it is, let's launch it as pure Rust code using the Rust dispatcher or whatever, right? So it's possible that over time, the share of Rust code will become larger, and that will encompass implementation from specifications like TCG or ACPI and stuff like that. But that's kind of where we're at now versus where we would go in the future with that, and our general path to getting more Rust code.
Okay, so and then, but by the way, that was actually thank you. That was what I was trying to get at. So you do see this as an evolution, as a gradual evolution, rather than a cut and move to a new platform type.
Yeah, I think we'd like to get, so right now we'd like to get platforms enabled meeting these requirements. We believe this will put the platform in the best position for safety to today's standards of what we consider to be a memory safe system. It's more stringent than what you would get with like a traditional EDK2 implementation, and it would position you to be able to accept those changes that come in the future, right? Because if you can't get to this point, it's going to be you're gonna have to do this plus potential future work. So this is kind of the baseline of where we're at today. And the roadmap, because this comes up often, is like, hey, we have all this stuff out there. Where's it going? We try to keep a roadmap down here, and we keep it high level because we're not being driven purely by requirements that we don't tie to practical value. And so if we realize that there's a use case, there's a platform out there where the practical value of doing something supersedes our current priorities, we will adjust the roadmap. But the current roadmap is this, right? So we want to continue component growth, and that means taking those C-based UEFI drivers, converting them to pure Rust. And whenever you look at the high level boot flow on a lot of platforms, we went for Dixie, right? And prior to Dixie, there's a lot of diversity in the platform boot space. People are going to either not have a PEI environment, they're going to come from a non-PEI environment and just create a hob list and jump into Dixie. There's lots of different things that are going to happen. So that's one reason why we targeted Dixie. It's very complex in terms of the software environment where we thought it would benefit best from Rust, but it also eliminates us having to handle each of those diverse set of platform requirements for the pre-Dixie side, and we can all just converge in Dixie. So that was part of this as well. But if you think about the boot from Dixie onward, ILM is a big part of that, right? So we load everything in Dixie. That essentially is our basis for loading the boot manager and going into an operating system. But then what do we have running alongside Dixie that we often carry? It's ILM. So that is why the ILM support is pretty high on our priority list. We'd like to get both of the cores from the Dixie launch point onwards written in Rust and part of the Patina project. So this is our high level roadmap here. And Oliver, I see you have your hand raised.
Yeah, I just wanted to apologize if you already mentioned this, but I know you mentioned the bin repo, but we do have this Patina QEMU repo, right, which is our equivalent of OVMF and ARMVert package, where you can see exactly how, sort of the end-to-end platform story is in terms of that evolution. So, our first platforms, including this Patina QEMU thing, are shipping with essentially you take out Dixie core and a couple of other small changes and you just plop in the Patina Dixie core and you're kind of good to go. And so that is really that, evolution process.
I know I didn't answer all of your questions.
No, you did. You did. And thank you, by the way. That was very, very helpful. Again, and Karan will know this is I have a lot of reading to do, especially also based on the ODP stuff that we just got involved in. And so it's very, very helpful to help point me in the right direction of where I start and what I need to get familiar with. Good. Thank you.
Yep. I will say a challenge that we have to work together on as a firmware ecosystem and community. This goes beyond what we can just control for the current people working on this project is being able to integrate this work into platforms that you work on, right? As you can see, a lot of us work at Microsoft. So we're obviously very bullish on getting this integrated into platforms that we can influence or we have more influence over. But out in the ecosystem, the real purpose of this work, it being open source and us trying to build a community is we want to be able to get this into systems out in the industry. And that's going to, I think, require a lot of collaboration and communication about how do we do that over time, as opposed to just like we send it out, right?
Yeah, I agree. And that's a really, really good point. I mean, yes, there's two ways of, or there's the one way is obviously open source, which is good. And what you guys are already doing. The second one is, OEMs are typically investment shy, right?
Yep.
And so, giving them some of this stuff in reference code from a silicon vendor perspective to help them, get to, I guess, the 70 or 80% solution, it also typically helps, right? So those would be from my experiences, and I guess looking at this, you're already doing that, so that's good.
Yeah, And that's just to add that like that feedback loop, and I think the community contributions are important. We do want everyone to be actively involved and be able to make sure that if there is something that is an obstacle for you, let's go ahead and file an issue, talk about it or whatever. We have these monthly calls where we can also discuss it in more detail if we need. But I think that's just that's another aspect to all of this work is there's just the community and the ecosystem part that we'll have to keep working on as we go through it. Are there any questions about it? Does anyone want to add something that I may have missed or give your perspective on the question? Because I think it was a pretty high level question. People may have other views or points they'd like to share.
Michael, do you want to talk about the readiness tool?
Yeah, you can go ahead and talk about it too, Vanil. I'll go over to the readiness repo and you can give your background.
So we have this repo called Patina Readiness Tool. So the idea here is to essentially whoever wants to onboard or use Patina can leverage this tool to first validate whether their platform is ready to use Patina or not. So essentially, it kind of does some sort of validations, like the requirements, what Patina wants for it to be used on their respective platforms. So this is a good start. So here what we basically do is kind of once we get the handover from PEI, we essentially, instead of using Patina, we essentially use this Patina readiness tool. All it does is kind of validate the hops and other FV volumes and stuff to satisfy the requirements for Patina. And it does give you at the end a report where you can see if there are any violations on your respective platform. So this is the report that we get, and then potentially once these issues are fixed, you should be good to go, at least to get started. And the repo itself has a released binary. So if you go to the repo releases, like you will find both a Dixie driver, which is what the Patina readiness tool itself is, and you will also find a Eufy shell app. So you can try both to get started.
Yeah, I think just to tie it together to what I talked about before, we have these requirements. We think, like I said, these are in the best interest of Patina and future facing platforms. But we know a lot of people are not going to meet these requirements today, right? People are likely going to be using a priori. Your drivers may not have the section alignment needed so paging can be applied properly in memory. There's this new resource descriptor hop type that's coming out in the PI spec that we've advocated for so we can better describe memory whenever we build the page table, more accurately describe it. So there's a lot of like good stuff going on, but at the same time, it's unlikely that if you were to just take a platform and run Patina on it, it's going to necessarily work, right? And the readiness tool is kind of the vehicle to be able to say, let's make a binary that will check these requirements specifically and then report out what needs to be done to help bring the platform up to the point that it can run the Patina Dixie core. And this is just to avoid a large portion of it is to avoid the problem that you try to build the Patina Dixie core, run it, and it doesn't work, right? And it's not exactly as clear why it didn't work as it could be if we just went right to the heart of the requirement and reported back its status. Oliver?
Yeah, and I just wanted to echo that. I mean, so we have these tools and documentation, but of course, we're also here to help, right? I mean, there's this meeting, but also you can reach out to us via email. All of us are available on Teams as well, and we want to understand, what's happening with your platforms. What issues are you hitting? How can we help, with this community adoption, right? We're very focused on that, and we'll be very responsive to help.
I just want to say it's really cool to have this kind of tool that analyzes it and tells us what's going on.
All right. Yeah, thanks.
I will try it out.
And don't be afraid to file issues either. Like and sometimes it's like hard to tell whether or not you have something substantial enough that it justifies a GitHub issue. Maybe you don't have all the evidence you think you need to be able to file the issue. We don't really mind if you file an issue to start a discussion. If we have to close it as we don't have any work to do, that's fine, right? We can do that. You can also start a discussion in the repo as well. So if you think, hey, there's something I want to discuss, but I don't really have an issue necessarily to discuss, back in the main Patina project, you can go to discussions and just start a discussion. We all get like email notifications whenever a discussion starts. So someone will come by and drop in for you.
Cool. Are you working with IBVs and chipset vendors to make sure that they support the requirements? Because most OEMs, we don't do the Dixie core and those kind of core code ourselves.
That is, I guess, a part of the reason for this call is to be able to have a opportunity for them to come explore what we're doing and look at it. I mean, we are reaching out individually, but I think that process will take a bit of time. We're hoping this call will help accelerate it if we can work together as much in the open as possible through it. Hey, Kevin, I saw that you joined just now. Thanks for joining.
Yes, thank you.
We did introductions at the beginning. Oh, go ahead.
As one of the IBVs, I'm joining.
Maybe a quick introduction from you, just for people who, I know you've done a lot of work in Tiana Core, in case they haven't worked with you before, on your background.
I've been doing BIOS since the 80s, 1980s, that is. And I work for Inside Software. I managed the kernel team and the silicon teams for decades, and have recently, or in the last 10 years, stepped back into more of a helper role for everybody.
All right, thank you. And that takes us back to our agenda and the Q&A. Any further questions that anyone has about the project or anything that would help if we explained it a bit more for you?
How does this compare to the new project?
Yeah. So our team.
Good question, Daniel. Very good question.
So our team, as you know, we're active in Project Mu. The core UEFI team runs that project in Microsoft open source. That is essentially a fork of EDK2. So it has a very different goal from this project. In terms of that one has EDK2 code with modifications applied to it. It might have some additional features and functionality enabled that is being shared to use in Microsoft products, but also make available to others to use in their products as well, and have an open source community. This project is completely separate from that, in the sense that we treat this as a standalone implementation that happens within a whole new organization. So you'll see we're an open device partnership. It's not under the Microsoft organization. And part of the reason for that is to give greater, even a perceived sense of greater ownership and greater ownership to the participants in the project that come in. So I think, Thorsten, I saw that you had already seen the steering committee and were interested in that. We hope that will give a strong voice to the different people in the community to be able to influence the direction of what we're doing and be able to drive it so that it works well on their platforms and processes. But the only real connection that we have there is if you go to that Patina QEMU repo, you will see that we essentially took this repository from a Mu repository for QEMU. And whenever you're going to boot or build firmware for QEMU, the most common implementation out there today is what's called OVMF package inside EDK2. That's what you'll see used in most places. Whenever we built this repository, we already had a repository that tested all the, like whenever I said Mu has a bunch of additional features and functionality and all that stuff, we, at the beginning of this repository, we said, wouldn't it be great if we could make sure all those work with the Rust Dixie core? And that's part of the reason why this was created from the Mu version of the QEMU firmware implementation. Whether or not we continue that or we go a different path in this particular repo is to be determined. But this is just a place where we test the Patina code. It's not anything that will end up in your code, right? So I think the main takeaway is that if you are using Patina, you're going to be using Patina code. You're not going to be using Mu code. Oliver?
Yeah, and just to make, I guess, a direct statement about that, nothing in Patina depends on Mu code. Now, I'm going to immediately walk that back and say, except for in a very temporary sense where we may have staged something there on its way to EDK2. But you'll notice a lot of us, I mean, Michael is an EDK2 steward. A lot of us are maintainers and reviewers. We have a heavy presence there as well. So definitely there will be no ties between Patina and Mu.
Apart from us using it on Mu platforms and testing it on Mu features, right? And so we will do that as like a downstream platform integration piece of all of this. But you wouldn't need to be concerned about, because it's like juggling all these projects, right? You're like, okay, there's EDK2, there's Project Mu, now there's Patina. How do I make sense of all of these? I think the easiest way to think about it is that EDK2, if you're using that today, you're still going to have to get your drivers from there because they're going to be dispatched in the Patina dispatch process, like I was describing earlier. But you don't need to get anything from you necessarily. You just need to come to Patina and grab the library crates and build your Dixie core. So you can kind of think about it that way in terms of the simple view, high-level view of all these. Did that make sense, or any follow-up?
Yeah. And then how does the ODP relate to Patina? Is ODP just doing Patina or encompassing more?
Yeah, I'll start with this, and since Karan's kind of at the higher ODP level, so I represent Patina on the what's called the ODP steering committee, and we have other projects that are part of ODP, like like EC, for example, is part of ODP, and in the future there may be more. So Patina is a project, an open device partnership, which is the larger organization, open source focused organization that this is being tracked under. And why do we put all this under a larger umbrella? And the reason is that we can share practices, we can share governance, we can share resources, and we can have better consistency where it is relevant between this different code. So if someone were to say, you know, I want to be able to take Rust EC code, I want to be able to take Rust UEFI code, and I want to have my system run with memory safe firmware using modern development practices, we don't want that to look significantly different between the EC work and the UEFI work where it doesn't matter. So if we have points of, if we can say, hey, there's an integration point that people are going to have to go through to be able to use this code, and we could do it differently. We could arbitrarily say that this is done in different ways, or we could make it simple and people don't have to worry about that. And that's part of the reason there. We also do things like share resources and infrastructure. So with Rust, you get this concern and problem of supply chain security. where you start to say, okay, Rust is great, but just like in Python and other languages that have these package managers with all of these different packages or pip modules or whatever language you're looking at and how they're organized coming in, crates are essentially the same thing. They have the same problem in that can I trust the code? Is the code compatible with my licensing and all those kind of questions? So at the ODP level, we've set up infrastructure to be able to check what crates we're using, determine if they're the correct license, and also we can share crate audits with each other. So if a security expert from one sub-project in ODP looks at a crate and says, this crate is deemed secure, I've inspected the code, I think the organization is okay to use it, we can pick up that audit on our side, right? And so it essentially just allows that more frictionless sharing of information and communication in the areas that are relevant between the sub-projects in the organization. And Karan, if there's anything you'd like to add there.
Yeah, no, I think you covered all the details. I think from a high level perspective, we had sort of shared goals of wanting to promote memory safe firmware on devices. And so within that scope, we have like two domains that we're promoting. One is the UEFI space that you're just looking at here on this meeting, and then there's the EC side. So just like Michael started this series, public series, you should expect like at least one more for the EC and probably one more for sort of the overall ODP governance side. We'll be looking to start that as well. So yeah, it's the organization sort of has supported is including like sort of those two firmware domains.
And I'll just make the same direct statement that there is no dependency between Patina and any other repos in ODP. So you can use, both multiple sets. You can just use Patina. You can just use, other stuff in ODP. There's no tie between them.
And a part of our experience with open source projects is that there is a factor of administration and community that matters in those projects, right? We think that having the right governance process, making decisions the right way, and following sustainable processes are going to help us solve the problems of the future, however they best can be solved. So we can't sit down today and think about everything that's going to happen in the future and how to solve it. But we think that if we can sit down between these large projects that are like-minded, thinking about memory safety, working on low-level software, and we can say, what's a process where we can put the right people in the right positions so that we can make decisions as based on the best data as possible in the future, right? And that's part of what the administrative governance side of ODP helps provide. It's being able to set the processes in place. You'll see, like, even on the steering committee, we did things like have 1 year term limits. So I'm representing Patina for a year, but a year from now, I will essentially reapply to represent Patina. It's possible someone else will take that position. If I move on and I'm not as actively involved in Patina, I'm not stuck having a vested interest in the project that's not taken away from me. And so we've tried to put the administrative and governance processes in place so that we can sustainably support this project going forward with a community of industry participants. So they have an opportunity to have an equal voice, and also as their participation may come and go, we can basically pull them in or remove them from the decision-making process. So that's part of the ODP level role in the work we do. Okay, great questions. Are there any others?
It sounds like the Patina, the Dixie core is usable or close to usable if you meet the requirements. What about the EC?
So the closest person we have to that project is Karan here. I guess that may be a question to hold until the EC public meeting, but I don't know if there's anything, Karan, you can mention now about.
Sorry, that was the question. I think the question. Can I rephrase the question we were asking? Looks like Dixie Core is ready to be used across design. Is from a readiness perspective, is the EC platform at somewhat the same space as the Dixie Core? Is that the question?
Yes. What's the status?
Yeah. So I would say we are in a very similar spot on the EC side, depending on which silicon that you're picking and so forth. We can't talk about specific designs that we'll be using either the Patina or the EC in this forum, but there are, I mean, in the next sort of 2 to 3 months, you should be seeing some devices coming out that actually use both the Patina core as well as the embedded controller.
Will it be known after they are announced that they use this?
Can't speak on their behalf. I would suspect they will talk about it, and I'm pretty sure we'll be able to talk about it in this forum for sure. So you will know when that happens.
All right, cool.
All right, we have 4 minutes left, so we're getting toward the end of the meeting. If we go back to the agenda, we were going to go into some of the RFCs if we had a bit of time, but otherwise, are there any other questions? Okay. If not, I think with the time we have, we won't be, we normally will go into slightly deeper discussions on each RFC, but I'll kind of just show off what's out there. And if you are interested in getting involved in the project, a great place to start is these RFCs are meant to be high level requests for feedback, right? So if you have expertise in a particular area that there's an RFC for, you may not even really need Rust experience to be able to provide value to that RFC by giving your feedback on it. So some of the ones we have now is one to propose downstream build options for Patina. This is to make platform integration easier, essentially, for platforms using Patina. We have one to reorganize some of the device path code within the code base. So if you are familiar with device paths and connecting devices and that aspect of boot, you could look at the way the code's organized here and perhaps provide feedback. A big one that goes into our MM goals as part of the roadmap is this Rust Supervisor RFC. This one here is kind of the basis for what we're planning to do in MM. And whenever I was saying we aren't just enabling simple, environments that meet the requirements for the phase goals, we modernize and try to make things as safe as possible. Having a supervisor inside MM is part of that, and that's what this RFC talks about. So this would be a good one if you're interested in that to take a look at. The WSSI team here is exploring a simpler, modernized BDS type environment as part of boot, and that's being tracked in this boot orchestration component. And you'll see component is indicative that this is written in pure Rust, right? So we call these things the pure Rust subsets of code that we plug into the Dixie core, we call those Patina components. So this is talking about essentially making boot orchestration into a component that's all written in Rust. There's one down here for runtime service module support. Runtime services are tricky because of the memory that persists through runtime, and that's kind of what this covers. And we have one here for build system interop as well. So that's what's out there. But otherwise, thanks for joining, and I'll stop here and look forward to seeing you in the next meeting. All right, thanks everyone. Bye.
Thanks.
Thanks.
Thanks, everybody.